Good morning, class. Today we will be starting mesh analysis. So far we have studied the basic laws and the circuit analysis, nodal analysis, right? So we will start today mesh analysis. So to solve the problems related to mesh analysis, you need to study a few steps. You need to memorize or remember a few steps. So these are the steps. So first you need to assign mesh currents. When you get a circuit, when you analyze a circuit, you need to find the nodes first. Then you need to find how many loops are there, independent loops. There should not be overlap of loops. So those you have to mark with mesh currents. Each loop will carry different mesh currents. So you have to name them individually with I1, I2. If you have n number of individual loops, you have to name them till In. So this is the first step. Then the second step is you need to apply KVL to the number of loops. So this is the second step. You have to apply KVL to each of the n meshes. So if you have n number of loops, so you have to apply KVL to each of them. Okay? Then you will get an equation, and you have to use Ohm's law to express the voltages in terms of mesh currents. So if you get a equation related to voltage, you need to convert that voltage using Ohm's law. You have to, you know that V is equal to IR, right? So you have to represent this voltage in terms of current. So it should be, yes, V is equal to IR. So you have to replace the voltage with IR. Okay. So this voltage will be replaced by IR. Suppose you have an equation with V1 plus V2 is equal to 3. So you have to replace this V1 by I1R, I2 R2 equal to 3 in this form. To all of the equations you get. Then the third step, you need to solve the resulting n simultaneous equations to get the mesh currents. So this is the final step. So you will get the number of equations like 1, 2 or 3 equations. So you need to solve those equations to find the unknown currents, mesh currents that you have declared in your circuit, I1, I2. The unknown terms you will be able to find from there. So these are the steps you need to remember while solving the mesh analysis circuits. So let's solve one circuit related to mesh analysis, okay? So So the current over here, which you are seeing, is the branch current. These are not the mesh currents, okay? So first you have to identify the number of nodes. So this is one node, this is one node. So these are the two major nodes. So at this node, the current is getting divided into two other branches. And at this node, this is basically the reference node, okay, connected to the ground. So the first step, if you remember, you need to find the number of loops, individual loops. So you have two. Here is one, here is one. So this is loop 1, this is loop 2. So you need to name these loops in terms of mesh currents. So this is mesh current 1 flowing through this loop and mesh current 2 flowing through this loop. So these are the two mesh. So you have to apply KVL in these two loops. So this is one mesh loop, this is another mesh loop. So you name them first. Mesh 1 which carries I1 current, mesh 2 which carries I2 current. Now you have to apply KVL to each of these mesh loops. So when you apply KVL to this loop, so you have 15 volt here, you have a voltage drop here, you have a voltage drop across this 10 ohm, and you have a voltage source here. So you will be able to find a equation from here using KVL. So this is a voltage source, this is supplying, so we will consider this as negative. This is a voltage drop, so this is absorbing, so consider is as positive. So here mesh current is I1, so this I1 times this 5 ohm will give you the voltage drop over here. So I1 is flowing in this direction, so I1 times 5 ohm will give you the voltage drop, so it will be positive. So 5 times I1, sorry. And there is another resistance over here. So you have a I1 flowing, mesh current I1 flowing in this direction, but you have another mesh current I2 flowing in this direction. So you have to subtract them and take the difference. The bigger current is I1, so as this is the primary mesh you are using, and this is your secondary mesh in this case when you are using this loop. Okay, so I1 is a bigger current, I2 is the small current, so your resulting current should be in this direction. So I1 minus I2 times 10 ohm will give you the voltage drop over here. Then you have a 10 volt which is present over here. So this 10 volt, if you consider this as negative, this mesh current is going out of this positive end and entering this positive end. So this will oppose this source. So this will be plus 10 volt, which should be equal to 0. So this is your KVL, right? Kirchhoff's voltage law. So sum of all voltage drops should be equal to 0. So this is equation 1 from mesh 1. You simplify this, you will get equation like this. Okay, if you simplify that, you will get equation like this, and then you have to apply KVL to mesh 2. So this is your primary mesh now. When you are applying when you are using mesh 2, this I2 current will be your primary current. So just remember that. So this is your voltage source here. There is a voltage drop over here. voltage drop over here, voltage drop over here. So you have to apply KVL in this loop for this one. And I2 is your primary current. So I2 is flowing through over here. There is I1 flowing down over here. While you are using this one, mesh 1, this was your primary current. But while you are using mesh 2, I2 is your primary current for this resistor. So if I2 is your primary current, I2 should be bigger than I1. So the current difference over here, the resulting current should flow in this direction. So I2 minus I1 times 10 should be the voltage difference over here. But this is your voltage source here. So this will be negative, right? As this is supplying. So minus 10 volt plus I2 minus I1 times this 10 ohm will give you the voltage drop across this resistor. Then I2 is flowing through this 6 ohm. So I2 times 6 ohm plus I2 is also flowing through this resistor. So I2 times 4. There is no more voltage drop, so should be equal to 0. So this is the second equation which you get. And if you simplify this, you will get equation like this. So this is equation 2. Let's say this is equation 1, okay? When you simplify this, you get this. Name the equation 1. Now you have to solve these two equations simultaneously to find I1 and I2 mesh currents. So if you solve them simultaneously, your I1 comes to be 1 ampere. Okay? Just solve them simultaneously. Put this I1 in equation 1. So if you replace this I1 with 2I2 minus 1, you can easily find I2 from here. Okay? So when you find I2, your I2 will be equal to 1 ampere. So this 1 ampere, when you put over here, it becomes 2. 2 minus 1 is also 1. So I1 is equal to 1 ampere. I2 is also equal to 1 ampere. So these are the unknown terms you were asked to find. These are the mesh current you were asked to find in your question. So if you know I1 and I2, you can also find capital I1, capital I2 and capital I3. If you observe, this I1 is flowing through this 5 ohm. This capital I1 is also flowing through this 5 ohm, and both of them are in the same direction. So your capital I1 should be equal to your mesh current I1. Similarly, this capital I2 is also equal to mesh current I2. If you observe here, this I2 is flowing through 6 ohm, mesh current I2 is flowing through 6 ohm. This capital I2 is also flowing through 6 ohm. So this capital I2 is also equal to small I2. So when you know I1, capital I1 and I2, apply KCL over here. So if you apply KCL at node, let's say this is node 1, name it. So node 1, what you get? At node 1, this capital I1 is entering and this capital I3 and I2 are leaving. So capital I1 should be equal to capital I2 plus I3. This is the equation when you use KCL. Okay? So you know I1, which is 1, you know I2, which is also 1, so you can find I3 from here. Your I3 current should be equal to 0 ampere. Okay? So you have found all the unknown parameters in your circuit. So this is how you solve mesh analysis problems. Now you might have a mesh with a current source. We will solve that kind of problem in the next class. Today I am ending the class over here. Thank you so much for listening.